Hi engineering leaders, I'm Mike Thumbs, Head of Customer Success at Waydev. We developed an engineering management platform which connects to your CI/CD platforms in order to help you measure and analyze your team's DORA metrics. So you may be familiar with the concept of DORA Metrics. They were actually developed by a team at Google, and they are designed to help you measure and optimize software delivery performance. So the metrics are the deployment frequency, which tells you how often do your teams deploy changes, the lead time, which tells you, okay, how fast does code committed get deployed, the change failure rate, which tells you how often do deployments fail, and then there's the mean time to restore, telling you how fast actually do deployments, how fast can a team issue a successful deployment from the moment a failed deployment occurred.
Hi engineering leaders, my name is Vincent Radulescu and I led the development team which integrated CI/CD providers and DORA metrics into our platform. We will now talk about each individual DORA metric from a more technical standpoint. First of all, deployment frequency, which most consider the most important metric. It shows how often do teams ship code into production. A common misconception about deployment frequency is that if teams deploy code more often, then the risk grows, because if the total number of deployments increases, then the risk incident might also increase. But the truth is that it's the complete opposite. If teams develop a healthy behavior of shipping more often but with less code, then the risk actually goes down. So for deployment frequency, the key idea about it is to ship code often but less. Because if you ship less changes into production but on a more often pace, then it is much easier to both identify the faulty deployments and fix them faster. Okay, the next DORA metric, which is also extremely important and in direct correlation with deployment frequency, is lead time to changes. Lead time to changes can actually be viewed as more parts united into a single one. Because actually lead time to changes is comprised of the time between when a commit is issued and also a PR is issued, so the time from commit to PR issued, plus the time between when the PR was issued and when it was first reviewed, plus the time between when the PR was reviewed and it was actually merged. And then on top of this, we add the time it took for the PR to be shipped into production from when it was actually merged. An important aspect in improving your lead time to changes, which a lot of big companies tackle with, is that the testing part of implementing the changes into production takes days, if not even weeks. So the healthy behavior for improving your lead time to changes is to actually teach your developers to do automated tests, because this will save you a lot of time. Not only do a lot of tools for creating automated tests exist right now, but you are basically cutting out the whole testing process, which, as I said, may save you a lot of weeks. Okay, next up we have change failure rate. When thinking about change failure rate, the first error that comes into my mind is that a lot of teams actually look at the total number of failures instead of the failure rate, which is the total number of failures divided by the total number of deployments, which if you look at it this way, you will see that actually failures occur less often than you may think. Of course, it varies from team to team what they may consider as a failure, because some teams may think of a failure like a failed deployment, so a deployment that simply failed to build, while others consider a failure deployment that actually went into production but was quickly rolled back because it yielded an unhealthy behavior. So it is very important for your team to actually find out what they consider a failure. And another very important aspect is to include your developers in the whole deployment process. So ideally, your developers should also do the deployment, because including your developers in the deployment process not only encourages them to participate into other activities, but also if something is going wrong, the developer took part in the deployment process and he knows what exactly he shipped and what may have gone wrong. So next up we have MTTR, which stands for mean time to restore. What is important about MTTR is that we have to understand that mean time to restore is only a piece from the whole incident response plan. First of all, you have to focus on quickly detecting the issues that went into production and caused the unhealthy behavior before actually improving how short does it take to fix them. So when we are talking about MTTR, the DORA team at Google found out that elite performers are actually able to restore services to their healthy behavior in under just a couple of minutes, which sounds extraordinary, by using a very powerful concept called feature flags. So what feature flags are? They are toggles which allow DevOps teams to instantly roll back a failed deployment if it causes unhealthy behaviors. So by implementing feature flags in your whole deployment process, you are actually able to cut down the mean time to restore from maybe days, if it took days to roll back the deployment and issue one correct one, to just a couple of minutes by just toggling the failed deployment off in production.
So the DORA Metrics team aggregated some industry benchmarks to help you see how do elite, high, medium, and low performers scale up in terms of all the DORA metrics. So for deployment frequency, elite teams deploy on demand. Yeah. Now, high performing teams deploy on a daily basis. Medium performing teams deploy on a weekly basis. And then low performing team deploy on a monthly basis. Now, for lead time, elite performing teams actually deploy in less than 1 hour. High performing teams deploy between 1 hour and 1 day. Medium performing teams deploy between 1 day and 1 week. And then low performing teams have a lead time of 1 week to 1 month or even more. Now, for change failure rate, elite performing teams have a change failure rate between 0 and 15%. High performing teams have a change failure rate of between 15 and 30%. Then medium performing teams have a change failure rate between 30 and 45%. And then low performing teams have a change failure rate of above 45%. Now, the mean time to restore for elite performing teams, they restore services in minutes. High performing teams restore services in hours. Medium performing teams restore services in days. And then low performing teams actually restore services in weeks.
Okay, so I previously mentioned about tracking your DORA metrics into our platform. The CI/CD providers we currently support are GitHub Actions, for the Azure part, we integrate with Azure Pipelines. For Bitbucket and also GitHub, we offer integration with Circle CI. We also integrate with GitLab CI/CD. And for bigger teams that focus mainly on enterprise services, we just developed an integration with Jenkins.
Now, if you don't see any of your CI/CD platforms that you currently work with, we'll be more than happy to work with you and integrate it into our platform, right, Vincent?
That's correct, Mike.
Yeah, so we're looking forward to starting a POC with you and helping you measure and optimize your team's DORA metrics.